Hello, welcome to Chapter 2, Functions and Their Graphs. We're going to begin by looking at Section 2.1, the Cartesian Coordinate System. So, the Cartesian plane, 4 quadrants, divided by these two axes, the y-axis and the x-axis. We should understand that the quadrants go in counterclockwise direction, beginning right here with number 1, quadrant 2, quadrant 3, quadrant 4. All right, so looking at this illustration, if you're looking at a point in quadrant 1, both the x and the y are positive. Point in quadrant 2, the x is negative, y is positive. Quadrant 3, both coordinates are negative. And in quadrant 4, you've gone positive x and negative y. If there is a point on any one of the two axes, then one of the coordinates will be 0. Specifically, if you're on the x-axis, then the x-coordinate will be any real number and the y value will be 0. If you look at any point on the y-axis, then the x-coordinate must be 0 and the y value could be any real number. The next topic in section 2.1 is the slope of a line passing through any 2 points. So the slope of any non-vertical line through any 2 points is equal to what? The difference of the y-coordinates all over the difference of the x-coordinates. In other words, you learned this probably years ago. It's the ratio of the rise over the run, okay? In simpler mathematical terms, it's delta y over delta x, okay? Delta indicating change. That's that Greek letter there for change. If the x's are equal, then of course you would have a 0 in the denominator, and in that case you'd be looking at a vertical line, all right? So if you are trying to determine the slope of 2 lines and you get an undefined situation, then the line would actually be a vertical line. All right, so horizontal lines are always in the form of y equals some real number, where the slope is always 0, all right? A vertical line is always in the form of x equals some real number when or where the slope is undefined, like I just discussed. Okay, a little acronym here would be this, maybe to help you remember. Okay, HOI-VUX, HOI-VUX. Okay, so H for what? H for horizontal lines. O is really not O, is it? O is really a 0, okay? The slope is always 0, and it's always in the form of y equals a number. It could be any real number, okay? V for what? Vertical lines. U for what? Oh, the slope is undefined slope for vertical lines. And the equation of a vertical line is always x equals a number. The last thing I want to look at in section 2.1 are parallel and perpendicular lines. So, given any 2 lines, if their slopes are the same, if the slopes are equal, then the 2 lines are parallel. If the 2 slopes are negative reciprocals of one another, then the 2 lines are perpendicular. So an example here would be like if the slope of one line is equal to 1/3, then that would mean that the slope of the other line, m sub 2, just for the slope of the second line, would have to be what? The negative reciprocal of this is negative 3/1, or just negative 3. So these 2 lines would be perpendicular, again, because their slopes are negative reciprocals. Another way to look at it is if the product of these 2 slopes equals -1, then the 2 lines are perpendicular. Another quick example, let's say the slope of some line, m sub 2, is negative 3/4. That would mean the slope of some other line, and again, these are just subscript values, just representing whatever line we're talking about. Doesn't matter the order here. The negative reciprocal of this would be what? A positive 4/3. Do you see that if you were to multiply these 2 numbers together, you would indeed get a -1. Therefore, the 2 lines would be perpendicular. Okay, let's look at our first example. In this example, we want to find the slope of a line passing through these 2 points. So We're going to use our slope formula here. And it's the difference of the y's, so that's 6 minus a negative 8. Make sure you use parentheses accordingly here. Also what? Negative 5 divided by negative 5 minus 2. So that's going to be what? A negative times a negative is a positive. So we get 6 plus 8. 6 plus 8 is 14. All over minus 5 minus 2. That's a negative 7, which is negative 2. So the slope of a line passing through these 2 points would be negative 2. Now, wait a second. What if you said, oh, I didn't do it that way. I used this y value first. Well, that's okay. Doesn't make any difference. So the difference of the y, so negative 8 minus 6, negative 8 minus 6, all over what? Difference of the x's, 2 minus a negative 5. Guess what? You still get negative 2, okay? What you have to be watching for are how the numbers are aligned vertically. The numbers that are aligned vertically always come from the same ordered pair. Do you see that? The numbers that are aligned vertically always come from the same ordered pair. That's always going to be the case. And the second thing that's always going to be the case is the y values are on top and the x values are on the bottom. This is a graphical example. We are still asked to determine the slope. Well, let's just look at the x-intercept and the y-intercept. And then we could just count, couldn't we? I mean, this is 1, 2. That's negative 4. So we would go up. If we're counting here, we go up 1, 2. The rise is positive 2. And then the run would be what? 1, 2, 3, 4. So rise over run, 1/2. There's your slope. We are still trying to find the slope of the given lines. These are two special cases. Why? Because this is a vertical line and this one is a horizontal one. So if you paid attention to my little HUX-VOY acronym, you should understand what the slope is. Slope of a vertical line is always what? Undefined, okay? Undefined. Because if you did the difference of the y's or the difference of the x's, notice the x's are always the same here, right? This is always going to be x equal to some real number. Well, the x values, the x coordinates are always going to be equal to whatever this real number is. So when you subtract those two identical values, you get 0 in the denominator, making the slope undefined. Over here, you're looking at a horizontal line where y is equal to any real number. Now, the y values will be the same, but the x values will be whatever, okay? They could be anything, but they're going to differ. All right, so here, the slope equals 0, okay? 0. In our final example in section 2.1, we want to determine whether the lines through these pairs of points and these pairs of points are going to be parallel, maybe perpendicular, or maybe neither. All right, we're asked specifically, are they parallel? But you know, you can check for all three here. So what are we going to do? Well, the first thing is we got to figure out the slope of what? The slope of line AB. That's going to be equal to what? The difference of the y's. Difference of the y's over what? The difference of the x's, which would be this. And so we get what here? We get 15, because a negative times a negative is a positive. 4 plus 11 is 15. In the denominator, negative 3 minus 2 is negative 5, so we get a negative 3. All right. Okay, so now we've got to look at the slope of the line going through CD, okay? And let's see what we get. Difference of the y's, 8 minus a negative 1. All over what? Difference of the x's, negative 2 minus 1. Again, a negative times a negative is a positive. 8 plus 1 is 9. And then negative 2 minus 1 more is negative 3. And we get negative 3 again. Oh, so since the slopes, right, are equal, then what do we have here? The lines are parallel. Okay, fantastic. Now, if one of these happened to end up being equal to a positive 1/3, if one of these were equal to positive 1/3, then the two lines would be perpendicular. If neither one of those conditions were true, then it'd just be neither. They would neither be parallel or perpendicular. I hope you enjoyed section 2.1. Have a good day.